everyone and welcome back to RNM LABGH. Today I'm introducing a new format on the channel, RNM Inside. The other day I had a problem with my water pump. It stopped working and a part of the electrical line went down with it. I went to investigate the situation and I finally found the fault. The magnetic thermal circuit breaker you see here on the bench was burnt out. I've already replaced it with a new one because repairing these components is not possible and, most importantly, it's not safe. So today we're going to open it up together. We'll see what happened inside to understand the cause of the failure. It's the perfect chance to discover how this essential device, crucial for both home and industrial electrical systems, is built internally. As you saw at the beginning of the video, I used a multimeter to check the continuity on both poles. This is a double pole circuit breaker, meaning it interrupts both polarities, phase and neutral. This is important because in 220 volt alternating current we have phase and neutral, whereas in direct current we have positive and negative. Alternating current, when viewed on a graph, forms a sine wave. Direct current, on the other hand, is linear, with a constant positive and negative pole. I am putting a graphic comparison up here for you to see. To open the circuit breaker, as you saw, I had to use a drill to remove the aluminum rivets holding the 4 pins. Because of this, once opened, it cannot be put back together. As soon as I opened it, I found the fault immediately. As you can see, the contacts are completely burned. As you may have noticed, there are several components inside this device made of different materials: iron, copper, and plastic. Of course, the main contacts are made of copper to ensure solid and conductive connection. The rest of the mechanism consists of pins and springs that allow the internal hooking and unhooking movements, operating the contact linkages. This circuit breaker has 2 key functions. First, it allows us to manually cut off power to the electrical line it's installed on, so we can work on the system safely. The second function, which is vital, is automatic protection. If a fault or a short circuit occurs on the line, which in my case control the water pump, a light bulb, and an outlet, the breaker trips automatically. This immediate response prevents further damage to connected devices and, most importantly, helps avoid fires or serious electrical hazards. This is an essential device in any electrical system for the protection of our homes and our safety. I've sorted and separated all the different parts. I'm going to salvage them because this is all material that can be useful for my future project. As you've seen in my videos, I recover everything. Sooner or later, every component can be used for a new idea or repair. I want to show you exactly why the circuit breaker failed. The plastic linkage for one of the two contacts broke, specifically the one we measured with the multimeter that was no longer conducting. The failure of the plastic lever prevented the contact from closing properly, creating an internal electric arc that burnt the components and tripped the protection. By inspecting the inside, we've confirmed the problem was limited to this device. This means the rest of the system is fine. The water pump, the light bulb, and the outlet are all okay. It's crucial to check the inside of the parts we replaced to understand the actual cause of the failure. In my case, the pump could have been the cause, but thanks to this inspection, I'm now certain the fault was only the breaker itself. We've reached the end of this video. I hope you enjoyed it and found it useful. If you want more content from the R&M Inside series, let me know in the comments. Subscribe to the channel, share, and hit the bell icon so you don't miss the next videos. Thank you for watching, and I'll see you in the next project.